Hey there, future viewer. It's been kind of a long day work-wise, but I thought before I head off to sleep, I'm gonna try to knock out an Advent of Code puzzle. We'll go ahead and dive right in. Just a quick disclaimers: not aiming to be the best, intentionally avoiding writing very short amount of code. Okay, top right. Today's situation: we are in day 3, binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, no puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate two new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given these, I believe there are 12 numbers here. In the first column, there are 5 0 bits and 7 1 bits. The most common bit is 1, therefore the first bit of gamma is 1. You continue this process until you go across all 5 bits, and you get this for your gamma rate. When you convert this binary number back to decimal, you get 22. On the contrary, the epsilon rate is calculated rather than using the most common bit, we use the least common bit from each position. So you'll notice that this binary number is, in some sense, a complement or switching to ones and zeros of the previous one. So the epsilon rate switches all the ones and zeros of the gamma rate. And we have for the epsilon rate, the conversion to 9 in decimal. And then finally, so that we could produce simply one number to submit back to Advent of Code, as they requested, you would multiply the gamma rate by the epsilon rate. They have a note down here, be sure to do this in decimal. And then that would be your power consumption. Alright, so let me open up my Advent of Code folder. Just my own style here. We're going to for December 3rd, we're going to leave a space for the input. We're going to leave a space for the example. So the example binary codes are these here, these 12. And for the puzzle input, you'll notice that each binary code is longer. I believe it's 12 bits at this point, and we have many more codes to deal with. Be careful not to have an extra n line there at the end. Go ahead and open up RStudio. We'll dive right in. I'm probably going to use some tidyverse at some point today. And we have our documentation. Well, whoops, gotta save this code file. And now, in our coding environment, we will have our input and examples data ready for us. So here in the top right, we can see that we have our 12 strings, each 5 bits long, or each 5 characters long. And let's see, I think I'll want to keep track how many binary codes there are. And also, I'm gonna call that M. And also, how far across the bits go. I'll use the string lengths here. So M, we have 12 strings, and N, we have 5 bits across. Alright. I'm an R programmer, so I like to store things into data frames. And at the moment, we have this data frame with the puzzle inputs. According to the puzzle instructions, we're going to want to treat each column of binary bits separately. And we could break this down with for loops and some string splits like yesterday. But maybe taking advantage of some of the features that the R universe has. Let's see if we could press forward a little bit here. So we're going to split the puzzle input. I want to make new columns. That are called bit, and this is going from 1 through the number of bits, which is n. Let me see if I got my parameters correct there. Data column called puzzle input into, we probably need to specify what the separator is, because there's no space in between the bits. There's no space in the separator either. Now for the original data, I actually visually just want to keep it around, so we're going to tell R not to remove it. Now in our data frame, almost there, you can see what I'm trying to do. I'm trying to separate the bits like so. See if I could find a bug here. In my example file, there's should be just 5 bits across. Let me double check what I'm doing with this text here with the paste. Should be, that should be fine. I'm happen to be streaming and getting some nice feedback. Because if we go from 0 to n, what happens there? Thank you for your input. I have a hunch this makes this is two wrongs make a right, but it's actually going to help us. So now, according to the puzzle instructions, what we're going to do is look at the column for bit 1, see what's the most common number. Look at the column for bit 2, see what's the most common number, etc. So we need to eventually have some vectors called gamma rate and epsilon rate. I'm going to allocate some space for that. I'm putting suffixes for binary, just so I remember what the code is. So I think what I want to do, this is, again, not the most clever way. I'm just going to go across the data frame literally by column number. So for example, bit 1 is in the third column, bit 2 is in the fourth column, and we'll go from there. So we're going across the columns, we'll go from 1 to 5, 1 to n. And we want the number of ones in the jth column, but there are 2 columns to begin with, so we're going to move over to the third column for starters and ask however many numbers there are. Now for the number of zeros, we could take just n minus the number of ones, but the code will probably be easier if I leave it like that. Now, according to the puzzle instructions, the most common bit goes in gamma rate, the least common bit goes in epsilon rate. So if the number of zeros is greater than the number of ones, then the gamma rate has a 0 there, and the epsilon rate has a 1. Otherwise, we do this the other way around. Put the 1 in the gamma rate, 0 in the epsilon rate. So let's go ahead and run all this. Now our gamma rate is 1100 and our epsilon rate is 01001. Let me check that back with the puzzle instructions. So we have our gamma rate and our epsilon rate. Now in R and many other programming languages, we're hoping that we do not have to reinvent the wheel and convert from binary to decimal. So I think in R we could use the string to integer function. We're going to take the gamma rate and what I'm doing is I'm taking this 10110 and condensing it down so there are no more spaces in between the numbers. So now if I apply this string to integer function, I think we have to say it's a binary number, base 2, and then we got that value. And we're going to do the same thing with the epsilon rate. We got the 22 in line, just like the coding instructions. And if I just call these gamma rate decimal and epsilon rate decimal, we now take the two numbers, the gamma rate and the epsilon rate, multiply them together. We're going to get a product of 198, which is exactly what the example entails. So with that said, now I know that this works in the example. I could toggle all this, turn off the example, leave the input file on, and I'm going to run this code. Let's see here. And look at that, we got the first answer. Awesome. Give ourselves a pat on the back. Alright, moving on to part 2. Oh, jeez, this looks bad. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating values, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then keep only the numbers selected by the bit criteria for the type of rating. Searching discard numbers do not match your bit criteria. So bit criteria is down here. If you only have one number left, stop. This is the rating value for what you're searching. The bit criteria depends on the type of rating you want to find. To find the oxygen generator rating, determine the most common value in the current bit position, but keep only numbers with that bit in that position. If the 0 and 1 are most equally common, keep values with a 1. To find the CO2 scrubber rating, determine the least common value. Keep only numbers with that bit. If 0 and 1 are equally common, keep all values with a 0 in the position being considered. So for example, let me see if I could bring up the text file. For example, with these numbers here, we start off with 12 numbers. In the first bit, the ones were most common. So we're going to keep the 7 numbers that have the ones. And then we're going to go across the 5 bits in that pattern. Okay. Let me see where I am. So we got quite a lot to do in part 2. I think I understand what's going on, just still conceptualizing it in my head. I'm going to do a cheap thing. I don't want to accidentally obliterate the original data set, so I'm going to make a second data frame for part 2 from the first data frame. We're going to go across the rows from 1 to n. We still need the most common and least common bits. So we could probably recycle some code here. And what I want is something called most common bit, like that. Now there are a few more stipulations in the puzzle, so I don't want to forget about them. In the oxygen generator rating, for example, we have a most common value. But there's a possibility the number of zeros and the number of ones can be equal. So if we're going after the oxygen generator rating, we need to deal with the ones. And if we're going after the CO2 scrubber ratings, then ties or labeled with a 0, I should say. So maybe what I'll do is call this the oxygen key. Like that. careful here. And do the same thing for CO2. So oxygen key starts off with space for n numbers. CO2 key starts off with space for n numbers. Let me run all that. No errors, at least. The oxygen key is these here. The CO2 key doesn't sound right. So for the oxygen key, this 0110 is correct. But for the CO2 key, I want to do a complement. But if they are tied, then they go to 0. So let me see if that all works out. Going to see what these variables look like right after production. Actually, did not mean to repeat the numbers there. This is actually just a side item at this point, so it's not going to help us much. Okay. What I mean to say is that oxygen key are those numbers, the CO2 key are those numbers. And what we want to do is, according to the keys, we're filtering out the rows of the data frame until there's only one row left. So instead of calling this df2, maybe we'll call this df oxygen for j in 1 to 5, 1 to n. We're going to take this oxygen data frame, we're going to filter where what I'm confused about is if we could programmatically call the column names. I want to check the number of rows. That's not good. So what I'm trying to do is in df oxygen, take this matrix, go down to bit 1 column, and only keep the ones where we have, according to the oxygen key, the number 1. So what I think I could do is actually do this df oxygen in that column like that. And we're left with 1 row at the end, which is what we want for the puzzle, because we're keeping that number. We also, according to the puzzle instructions, once we get down to 1 row, we want to stop the process and break out of the for loop. And this is going to be called the oxygen generator rating. The first column I still have it left as puzzle input. And there's only 1 row, but we probably should ensure that's the row that's kept. So actually, we could do it this way. Puzzle input, collect the first one, and then the oxygen generator rating has that string that we want. Awesome. We're going to do the same thing for the CO2. I'm going to use the CO2 key. The CO2 generator rating. And now the CO2 generator rating. Is that right? CO2 generator rating. Whoops. Should be from df CO2 So then finally, sorry I'm not talking much, it's just a lot going on and we're all kind of exhausted, aren't we? The life support rating is, oh, we need the oxygen generator rating in decimal. So we're going to take the string to integer. And do the same thing for the CO2 rating. And then the life support system would be that oxygen rating in decimal times that CO2 rating in decimal. Actually, I had 2 commas there. That was a bit of a roundabout thing to do, so let me just read through that again. Part 2 roughly says you have to figure out what the so-called oxygen rating and the CO2 rating are. In a similar theme to part 1, you go through the bits left to right, keeping track of what's most common and least common, going roughly towards oxygen and CO2 respectively. Keeping only the observations, the rows that have the most common or least common bits, you keep filtering through the data frame until there's only one row left. Whatever is in that one row left, you keep that binary result as the oxygen and CO2 ratings respectively. And then finally, those were in binary, so we're going to convert these back to decimal and multiply the numbers together. So let's see here. I did not get the right answer. For one thing, I just realized that I did the calculations on the example. So let's see, where did I run wrong here? Got an oxygen generated rating of 22 and a carbon dioxide generated rating of 10, but the oxygen rating was supposed to be 23. Got a bug in my code somewhere because I know that my code's not even working for the example at the moment. And it's back up here when we were supposed to figure out the tiebreakers. Because I thought I had this. We're calculating the number of ones. We're calculating the number of zeros. If the number of zeros is bigger, then we input a 0. Otherwise, if they are tied, wouldn't that be a 1 there? So my oxygen key, why am I getting a 0? I didn't check this carefully enough when I was doing that bit of code. Could always try this. How about this? Why don't we say if the number of zeros equals the number of ones, then the oxygen key has to be 1. Else, if the number of zeros is greater, number of ones, like that. So now, the oxygen key is still incorrect. Maybe it's earlier in the code. In the 5th bit, the number of ones is 5, and the number of zeros is 7. Oh, now I know what I did wrong. I'm supposed to be checking the number of ones and zeros later. That is nice. Because you have to look at the remaining numbers. There it is. Let me see if I can salvage this. So we want to look at the ones and zeros, but as we're filtering through the data frame. So if number of ones is greater or equal to number of zeros, then the oxygen key is going to be 1, otherwise 0. Then we're going to filter on just that one number. Like so. So the oxygen generator rating should now be correct. There we go. that down here for the CO2 as well. But in the event of ties, we want this to go to 0. So now the CO2 generator rating. We want to double check all of that. Now the oxygen generator rating in decimals 23, CO2 generator rating in decimal supposed to be 10. That's not good. Gotta double check this. So in the CO2 rating, if the number of ones is bigger, pretty sure I'm gonna need to switch these. If the number of zeros is bigger than the number of ones, then you put in a 1 there. If the number of zeros is equal to the number of ones, you put a 0 here. And if the number of ones is bigger, then you still put a 0 here. Okay. So now the CO2 generator rating is this number here. If I convert that to decimal, we get a 10, and solving the puzzle, at least for the example, we get to 230. Look at that. Alrighty. So now, finally, what I'm going to do, from the very top, toggle off the example, toggle on the input. That's the data frame. I'm going to run all this. See if that's the answer. And we got it. Look at that. And it only took me twice as much time as I thought it would. Alright folks, so if you have watched this, thanks for dropping by, and I hope that you're either participating some way or another and enjoying Advent of Code as well. I guess until tomorrow.